Okay, so we've got this problem here. We see a plane directly overhead. 13 seconds later, we hear the sonic boom, so the plane is now over here. Let's assume it's going to the right. We have an angle here of 50 degrees. We're going to find the height of the plane. Okay, so what we got to keep in mind is it takes it 13 seconds to make this distance right here. Let's call this distance here, I don't know, maybe d1. Let's call the height here h. What's important to remember in these problems is the sonic boom is not coming from the plane directly down here. The plane was way back here before we even saw it. The plane traveled this distance in the time it took for the sound to travel this distance. So if we draw this big giant right triangle here, we'll call this angle theta. The plane was back here, creating a sonic boom. The sound traveled to us in the same time that the plane traveled this top distance here. So if we call this entire distance up here d2, call this distance down here d3, we're going to have a lot of d's here, then we could say this distance here, the sound traveled here, this is the speed of sound times our time. In the same time that the plane traveled this long distance. The plane is going faster than the speed of sound, so this top distance is going to be longer than this side over here. So this would be the speed of our source. Vs means speed of our source times the same time. That's not this 13 seconds. 13 seconds was only this little side right here. That's from when we noticed the plane until it got over here at this 51-degree angle. Okay, so we could say here, using this big triangle, this is a right triangle, opposite and hypotenuse. So sine of theta would be d3 over d2, which would be v, speed of sound in air, t over vst. Those t's will cancel out. We get v over vs. That's our formula for our Mach number or our cone angle. Like we already knew this formula. Sine of theta is v over vs. If we flip this over, vs over v, we call the Mach number. Mach number. And that's how many times the speed of sound we're flying. If we have a Mach number of 2, the plane is flying twice the speed of sound. So if we know the angle, we could use this equation right here to find the speed of the plane. Remember, Vs is the speed of the plane. V is the speed of sound in air. Vs means speed of the source. What we're looking for is the height of the plane here, the altitude, and then to do that, we're going to use this little right triangle here. That has a different time. This was 13 seconds. The whole trip up here on the top, I don't know, may have been 30 seconds. We don't know. It's more than 13. That was just this side here, from when we first saw the plane directly overhead until we heard the sonic boom. But the sonic boom was created way back here. We just didn't notice the plane until it was right on top of us. So anyways, we can use this formula to solve for the speed of the plane. So we can multiply that Vs over. Then Vs will be the speed of sound in air divided by sine of theta. So with our numbers here, That's a 50-degree angle, and we're using 325 for the speed of sound. 325 divided by sine of 51 degrees. So we throw that in our handy calculator, make sure we're in degree mode. We are. So 325 divided by sine of 51. 418 point, let's call that 0.20, 0.2. Meters per second. So that's an important number here. We're going to need that in a minute. That is the speed of the plane. Notice that's more than the speed of sound. We could find our Mach number if we were asked for it. Take that divided by the speed of sound, and it, we're going like 1.25-ish times the speed of sound. Okay, now we're just going to look at this right triangle right here. So I'll redraw it over here. This is what we're looking for, the height of the plane, the altitude. Now that we know the speed of the plane, what we call d1 here, we know how long it took, we know the speed. That's just going to be distance equals rate times time. This distance is 13 seconds times 418.2 meters per second. So d1 will be 418.2 times 13. So we already have everything in our calculator here. We can just say times 13. So that's 5436. Point, let's go to two places, 56 meters. And now we can use tangent. We know this angle right here, it's 51 degrees. Opposite and hypotenuse in this right triangle. Tangent of theta should be h over what we called d1. So h should be d1 times tangent of our angle. So that should be 5436.56 times tangent of 51 degrees. And again, everything's here in our calculator, so I can just do times tangent of 51. And then I avoid any rounding error that might happen in the middle. 6713. Let's say 59. Meters. And there is the height of the plane, which is exactly what we were asked for.